Folks, I now want to do an example of finding the derivative of finding a derivative involving an inverse cosecant function. So here's a question that somebody sent me from MyMathLab, and I'm going to go ahead and work through it. In the previous video, though, we showed that if f of x was the arc cosecant of x, we showed that its derivative is this, and so that was done in a previous video. As far as this absolute value goes, by the way our book derives the derivative of the arc cosecant, we do need this absolute value on here. But you'll notice that a lot of times the argument that MyMathLab uses will always be positive, and so you don't need an absolute value in your final answer. So if I lost you on that, let's go ahead and just jump into the problem, and I'll point that out one more time when we get there. So I'm going to go ahead and take the derivative of this expression. So let's see here, that gives me that dy dx is -1 all over the absolute value of x to the 8th plus 1 times the square root of, parentheses, x to the 8th plus 1 quantity squared minus 1. Okay. I'm not sure if MyMathLab will take this answer. I would encourage you to try it. Oh, and what did I forget? I forgot from the chain rule, I need to multiply this by the derivative of x to the 8th plus 1. So I need to multiply this whole thing by 8x to the 7th. So folks, I would encourage you to try, if you have a question like this, try this answer in MyMathLab. I think it will accept it. If it doesn't, let's do some cleaning up. First thing is we could rewrite this as -8x to the 7th all over, and then because this expression here is always positive, notice x to the 8th will always be 0 or a positive number, and then when I add 1 to it, it guarantees that the argument inside the absolute value is always positive. So we're just left with x to the 8th plus 1. And then we'd have times the square root of, and let's go ahead and, well, I'd like to leave the answer here for just a moment and say I am fairly certain that MyMathLab will accept this as an answer. So there's no need to simplify this further. But the student's question was, how do I get this into the form that MyMathLab says the answer is? So let's go ahead and keep working with that. So we get -8x to the 7th all over, parentheses, x to the 8th plus 1. And then I'm going to expand underneath the square root here. So foiling this expression out gives me x to the 8th times x to the 8th, which would be x to the 16th, plus 2x to the 8th plus 1, and then minus 1 left over from this minus 1 right here. We can continue to clean that up. That gives me -8x to the 7th all over x to the 8th plus 1, and then notice that inside the parentheses, or excuse me, inside the radical here, first of all, the plus 1 and minus 1 terms cancel. And then secondly, notice that I can factor an x to the 8th out of both those terms. So I'm going to factor out an x to the 8th times x to the, it would leave me with an x to the 8th here, plus 2. Okay. So notice that after I cancel these, this plus 1 and minus 1, those two terms, if I were to distribute this x to the 8th back through, I'd have the line above it. Okay, so I've factored out that x to the 8th. Be a little bit careful factoring with exponential expressions because sometimes folks make mistakes with that. Okay, so this gives me -8x to the 7th all over x to the 8th plus 1, and then what can I do? Well, here inside this radical I've got an x to the 8th factor, and I can bring that out as the absolute value of x to the 4th times the square root of just what was left in there, x to the 8th plus 2. Okay. Folks, if you're a little bit concerned about how I did that, I'll do a little explanation for this step here at the end of the video. Okay. But of course we don't need this absolute value on here. How come? Because x to the 4th is always positive or 0. If it's 0, then this whole derivative is undefined, but the cosecant curve to begin with isn't defined when x is 0. So we can go ahead and drop off these absolute values, and so we end up with -8. We'll have an x to the 7th, and then in the denominator we'll have an x to the 4th factor, so that gives me -8x cubed all over x to the 8th plus 1 times the square root of x to the 8th plus 2, and we should add to this with x not equal to 0. Okay. And so what? We're done. This would be the answer that MyMathLab would show you as the correct answer if you asked it to help you solve the problem. So folks, that was a whole lot of work. As a reminder, I believe that initially MyMathLab would have accepted this answer with the absolute values, but certainly if it didn't accept this answer, I really believe it should accept this answer here. But the question was, how do I go ahead and continue to simplify it to make it look like the form of the answer that MyMathLab is showing for its result? And that's how we would go about doing that. Okay. So that's all I've got for the video. If you have any questions about this simplification here, I'm going to talk about it in just a moment. But that's all I've got for the majority of the video. Okay, so let's look at how we did that simplification here. We had inside the square root x to the 8th times x to the 8 plus 2, square rooted, and I said that that should simplify to be absolute value of x to the 4th times the square root of x to the 8 plus 2, and then that should simplify to just to be x to the 4th times the square root of x to the 8 plus 2. So let's look at why that's the case. So I'm going to do this with sort of a simpler problem here. Let's just look at this problem right here where we have the square root of, say, x to the 6th times y. So we learned back in algebra that we have a square root product property where I could rewrite this product underneath the square root as the product of two square roots. So I rewrote it this way. The way you could look at that is say that square roots distribute over the operation of multiplication. Now be careful. If we had x to the 6th plus y, that would not equal the square root of x to the 6th plus the square root of y. So what do square roots do? Square roots distribute over the operation of multiplication this way, but square roots do not distribute over the operation of addition. So be careful with that. Now, in this case, I can now go ahead and simplify this because, well, if you're having a hard time seeing that, that's x to the 6th divided by 2 times the square root of y, writing everything as powers, which gives me x cubed. Now, when I pull this outside the square root like that, when I cancel these powers, I need absolute values on that. Okay? So I need to have an absolute value on that expression. Now, sometimes if x were negative, for instance, if x were -1, -1 cubed is still -1. So I would need those absolute values there in this case. But when we look at the example that I just did, we had an x to the 4th inside the absolute values, but x to the 4th is always going to be either 0 or positive, and so we do not need the absolute values, which is why from this line, I dropped them and then went ahead and did the cancellation step over here in the original problem. Folks, if you have any questions on that, please feel free to reach out to me. Let me know. Thanks.